Hello guys, welcome to all of you. Let us understand about basic of inductor and capacitor. Since these inductor and capacitors are basic element of RL and RC circuit. First of all, let us say about capacitor. If there is a capacitor connected in a circuit, then voltage and current relationship of capacitor can be given as ICT equal to C dVCT by dt. As we can see here that voltage and capacitor are linearly related here. So we can say that this is a linear relationship. And this type of capacitor are called linear capacitors. If we write voltage of capacitor, then it will be from this equation Vct equal to 1 by C integration minus infinity to t I tau into d tau. This integration can be break into two parts where this Vct naught is the voltage charge accumulated in the capacitor from minus infinity to t naught and plus 1 by C and integration of current from t naught to t. Here we can see that this voltage is due to charge accumulated from minus infinity to t naught. So its voltage depends on past value of capacitor. So we can say that capacitor is a memory element. Energy stored in a capacitor can be written by this formula. If we assume that voltage at minus infinity in capacitor was 0, or we can say that capacitor was uncharged at t is equal to minus infinity, then this term will be eliminated and energy stored in the capacitor will be equal to 1 by 2 CVC square into t. This formula is applicable only when we assume that initially capacitor was uncharged. We can find out the energy stored in a capacitor from interval t0 to t1 by this formula. That is Wt equal to 1 by 2 C into Vc square t1 minus 1 by 2 C Vc square t0. If capacitor is connected in a DC network, then current in capacitor will be equal to 0. Since the formula of current IT is equal to C dVt by dt. If there is a constant DC voltage source, then this term will be 0 and IT current will be equal to 0. So IT will be 0 if only DC voltage source is connected in the circuit. So capacitor will act as open circuit. Or we can see that if capacitor is fully charged or it is in steady state, then this capacitor will act as open circuit. Voltage across capacitor cannot be changed abruptly or we can say instantaneously. Since for discontinuous voltage, this derivative will be infinity and IT current will be infinite. So at discontinuous voltage, current will be infinite. So if there is a voltage connected in a circuit, then there will be no abrupt change in the voltage of capacitor. From this statement, we can see if switching is happening in a circuit at t is equal to 0 second, then voltage just before switching will be equal to voltage just after switching. That can be written mathematically Vc0 minus equal to Vc0 plus. An ideal capacitor only stores energy and it never dissipates. This question can be asked in 1 mark type questions. So an ideal capacitor only stores energy. If inductor is connected in a circuit, then voltage current relationship on inductor can be given as VLT equal to LdILT by dt. Current can be found out by this formula 1 by L integration minus infinity to t V tau into d tau. If we assume that current accumulated in the inductor from minus infinity to t naught is ILT naught, then this equation can be found out. That is ILT equal to ILT naught plus 1 by L t naught to t V tau into d tau. We can see that here current is accumulated from minus infinity to t naught in the circuit and that current is ILT naught. So we can say that inductor is also a memory element since it is accumulating current in its circuit. Energy stored in inductor can be written as Wt is equal to 1 by 2 LIL square t minus 1 by 2 LIL square at time minus infinity. If we assume that there is no current accumulation in inductor at t is equal to minus infinity time, means inductor was initially uncharged. So it will be equal to IL minus infinity equal to 0. So energy stored in the inductor can be written by this formula. If there is a time interval given t to t naught and a source is connected in the circuit for this period, then energy stored in this time interval can be written by this formula. If in the circuit there is only DC source is connected and current through inductor is a DC current, then from this formula we can see that there is no change in the current with respect to time, so this derivative will be equal to 0. So voltage across inductor will be 0. So we can say that voltage across inductor VLT equal to 0. Since voltage is 0 across inductor, so it will behave like a short circuit. Since current and inductor cannot be changed abruptly, so if switching is happening in the circuit at t is equal to 0, so IL 0 minus means current just before t equal to 0 second will be equal to current just after t equal to 0 second, that is IL 0 plus. Abruptly changes of current is not possible since if current is discontinuous at any time, then voltage will be infinity due to derivative of this current. Since infinite voltage is not possible in a practical circuit, so we can say that current will not change abruptly in a circuit. If there is an idle inductor, then it only stores energy. There will be no dissipation of energy in this inductor.